everyone. Yes, my name is Natalie Serebryakova. I am currently, I will be speaking about building microservices with Go today. And let's start from something about me. So I am a software engineer by my background. I have been working in very different companies, and currently I end up in senior software DevOps position. I also have 3 dogs, which is not on this slide. So today we're going to talk about scalability. So what I want to mention is the concept I'm trying to make, or the point I'm trying to make by presenting this talk today here is more a DevOps concept versus actual implementation. What it means is I hope after hearing this talk and listening to it, you will be able to learn or understand things at the level where current technology is going, right? That you could apply them. And I can clearly and honestly say that it doesn't have to be also like particularly with Go, could be probably any other language. That's why I hope this could be useful for any company you work, any team you work, because I understand not everyone doing certain things in one language. So let's talk about scalability as we started. What is scalability? So I think the system considered scalable, but it doesn't need to be redesigned in order to maintain effective performance, right? Especially when any application gets steep increase of the load. I hope that there is a chance to design application in a way that it can just perform as expected. So there are 2 directions. How do you scale? There is very famous vertical and horizontal concept, but there's also a point that not many presenters speak these days where company is scaling, right? When we hire more people and we start building more services or application microservices, whatever it is. So when you think about that, that's also good, because as an infrastructure team or as any other team, you're not just going to scale your own service, right? You're probably going to scale the whole product, and this has to be thought up front, meaning the tools you're building, any piece of your release and deploy process you're building has to be thought through. So what are the benefits when we saying we're going to build scalable architecture? We want to do it right in the first place. One of the benefits is basically if you do it right with initial prototype or proof of point, you probably don't have to rebuild it multiple times or refactor. As well as if your company or business is starting with good practices, right? You don't have to do a lot of refactor, waste your time, or build certain things, which could be sometimes not the best thing to work on. As well as if we think about things up front and not adding extra complexity, it's easier to scale. It's not just that, it's easier to grow. So currently, I hope, or I think a lot of people heard about microservices, and that's what we are going to talk about today. So there's I think this is from Wikipedia. If you Google what microservices architecture is, you will find the description that microservices architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms. This is nice, but when I think about my work and I think about my daily contribution within place I work or with people I work, I like to rephrase things in a way that all of us can understand. So basically for us, I would say scalability, microservices are ability to develop, deploy, and scale different business functionality independently. And basically, hopefully, microservice architecture can help us to do that. So this is how, kind of very abstract picture, how this whole architecture look like, or where we're trying to go with it. If anyone hearing this first time, you can get an idea what I'm trying to describe. Why are we decided to go with microservices? And you probably heard a lot of stories that these days a lot of companies have a monolith or had something in monolithic way and trying to break it in some smaller chunks. And why are we trying to bring this concept to the existence is because from perspective of scale, it's easier to scale small individual pieces of your infrastructure or architecture versus scaling one thing at a time, as well as it's easier to architect things, as well as it's easier to distribute them between the teams or between functionality. So at any point, things supposed to become easier, which is not always the truth, but that's what the main point is. So what it has to offer, once you're trying to reach this concept, you probably will get things like modularity within your infrastructure when everything has a purpose, right? It's a focus purpose, it's a focus on functionality, and basically, if, for example, one team owns one module, it's easier to build, grow, and scale this particular module, as well as maintain. As well as we can get the flexibility. Basically, as I mentioned at the beginning of this talk, that it doesn't lock you down with one technology, right? I know, like, in the places I work, we have different technology for different teams. Usually, probably, like, basic 4 is, like, backend, front-end, data team, trust and safety teams, right? Not every of those teams will use the same set of technologies. So with the flexibility, everyone can pick and choose the appropriate technology, which is easier for engineers or for the company, versus they have to break certain things in order to deliver something, which probably will be hard to manage in the future, will be not scalable, easy, and other pinpoints. Deployment. So I love to talk about deployments. It's one of my favorite things, deployment and release. I think that with microservices, it's way easier these days. The way how we can deliver our code, the way how we can deliver our product becomes very easy, as well as if I want to take or just deprecate something, it becomes very easy, right? We can just deprecate one thing instead of refactoring the bigger chunk, make sure once we push something to production, it didn't affect everything else. So you're becoming more flexible at this point. And I personally enjoy that this process, in general, can be improved. And the other thing which we are focusing today is scalability. So basically, as I mentioned before, every service can be scaled separately. You can play with different technology in order to learn how your service behaves, right? As well as you can build a certain strategy in order to understand how you should be scaling as you go. Depends on how you grow, depends how many maybe users you are getting monthly or daily. So let's go back to the Go language. What things we should be considering if we're trying to implement microservices using Go? So as I said, you can probably build it with any language. There are certain languages I wouldn't recommend, but these days a lot of languages are pretty much friendly. But microservice is more like a concept versus like set of instruction you should be doing. What I like about Golang, after trying good amount of different other languages, that it's very lightweight. It's fast. You can find many different frameworks how to build microservices. This is one of the benefits of this language. There's 2 other ones which have this, but I think Go currently have 5 good, solid microservice frameworks which you can use just at least to start and understand what are you trying to build. So functional requirements that you always should think when you're trying to design and build your service. Load balancing, service discovery, logging, circuit breaking, monitoring, alerting, or distributed tracing, or all of them, or either one you use, and of course security, which is very challenging these days. So how are we going to build microservices is one question, but the question which we should ask ourselves is what kind of technology we're going to use between service-to-service communication. It's important to understand how it's going to happen because the way there are like a couple technologies you can choose these days, but how fast it's going to be and how easy it's going to be onboarding your service is also important, and you should make sure you think about that. So by presenting this talk, I'm these days proposing using GRPC, which is a Google Remote Procedure Call. It's very easy. There is a lot of documentation online. You can already find a lot of examples. It's probably not easy to move your, if you already like started using microservices, it's probably not easy to move your old services, but you can use gRPC with already existing infrastructure and you can do it in a very easy fashion. So this is an example I wanted to show in order to like give you a basic idea how can you structure your package using gRPC, right? This is basically if you Google Go standards for package layout, that's what you will find, and adding gRPC to it probably will look similar to what I'm proposing here, or exactly like this. Some of you might ask, if you never heard about gRPC, why is it better? And maybe you already heard certain people talking about it and trying to show what it's really much what everyone should be using. One of the good things, it's already on HTTP 2, as well as it uses Proto Buffers. It's not a new technology, right? Proto Buffers existed before Thrift and more than 10 years ago, but this technology currently has down technology as that. And here I'm giving an example. If you're trying to compress certain information using JSON or protobuf, what kind of win in compression you are getting by just doing this. And there are other benefits. You can, like, this is really, really good when it comes to microservice communication in terms of speed and latency. gRPC also supports different types. In the old REST way, you probably get like client-server, server-client communication. Now with gRPC, you actually can get streaming. So you can get the bidirectional streaming just by using this technology, right? So you don't have to think if you want to use this technology, how do you design the whole thing with the current existing REST technology? You don't have to add any other extra frameworks. So you basically just getting this for free. So when we talk about microservices, very important is deploy strategy. I mentioned that before, and I want to, by showing this slide, bring this up again. So it's, I want to advise that if you are considering moving to microservices, or maybe you just started building your product and you are just deciding what kind of technology to use, is just use Kubernetes. If you don't know how to maybe spun up the cluster, it's pretty challenging. I did this. I started building clusters 5 years ago. By saying that, I mean we actually hosted Kubernetes locally by 2 previous companies I worked for. But I can tell that it's evolved, and if you use GKE, EKS, AKS, or any other cloud solution which already have Kubernetes, it's way easier. So I think you should just try, and it's really benefit you in order to build scalable application, because the concept of Kubernetes is actually pretty easy to understand, and it really makes easy things to build things in a scalable way. Another very hard question to answer is how do we test? So how do we test if our service is scalable before it goes to production? This is very tricky. There are some tools you can find. There is no language-specific tooling. Most of the tools I so far used are built in-house or built by my team. But you should probably rely on technologies like Docker when you have to like fade certain things or maybe create some patterns. And of course, make sure that CI and CD is implemented within your company. It has to be thought through as well. Another point is canary testing. Don't know if anyone heard about this concept at all or understand it fully, but basically canary testing will help you to understand what the expectation of your application or service is in production. So if you kind of at least thinking about the strategy of having this in your infrastructure during your deployment time, that will help you in order to understand what's going wrong with application, like right after the deploy. So this is a pretty cool concept. I would recommend to read on that. And because my talk is not about that, we're going to move on. So another thing is once you're scaling or once you release something to production, things can go wrong. I personally took down certain applications. I personally broke the production. And these days, with all what's going on, basically lots of microservices, people are committing code every hour or maybe faster or more often. You kind of need to have a strategy. If something goes wrong, what is your recovery, right? When you're scaling a lot of services, when you're doing lots of commits, lots of pushes, you need to think about scaling automatically as well as if something goes wrong, what is your reaction? And try to build a system which is smart enough maybe to do things like rollbacks. So if something goes wrong, you can come up with a canary testing. And if your canary testing is not passing or some weird things are happening, some different anomalies you didn't expect, you probably want to secure yourself with the rollback strategy, which helps in certain ways to avoid bad user experience, for example. As well as when you are releasing microservices, make sure that you use certain tools which are describing your service. Why it's important, I'll give you an example. These days, you release your service, and usually there are other services probably going to talk to your service and very dependent on what's going on. So let's say if you broke this contract between two services, it could be very crucial to understand what's going on once it went to production. So by using all of these tools, it's probably easier to maintain as well as kind of cooperate as one thing within a company. My favorite part is security. So whatever you do, whatever you build, please do it in a secure way or at least having security in mind. Why it's important, I guess all of us can agree that it's not good if you get hacked. It's not good if users who trust your product and uses your product are getting affected for no reason because of certain mistakes. So the other thing I can speak by working for so long and understanding the infrastructure of different companies is once the problem happens in production, especially, and if you have a big system to manage, it's really hard to debug and find a fix. Sometimes you have to revert, and you cannot find the cause what happened. So it's really nice if you can think about certain things up front, right? This is pretty cool these days using recent technology, Kubernetes microservices. There is a way of doing certain service discoveries. There is a lot of interesting material up there that you can probably read, or we can chat after my talk about certain technologies, certain ways, how can you do service discovery. Another very important thing, which I'm learning a lot these days, maybe I will prepare some talk about monitoring and, of course, observability. Why this became so important to me that I realized in some cases working with different level of experience, people with different level of experience, not everyone understands what's going on. Basically, example I'm trying to give is once you build your application or code at your feature and push your code, you need to understand what happens after that. Like if you make the baby and let it go to school, you want to know how your baby is performing, right? What kind of things are happening. So you should at least have a tool where you can look, maybe a dashboard, preferably a dashboard, or maybe many dashboards where you can understand what latency, what CPU, what other things your application is using in order to understand, is it actually even working? Is it actually getting in traffic? And another thing I'm noticing that not every company trying to provide that, as well as not everyone has access to it. So make sure, like, once you are a person who contributing to production, that you understand what you are delivering by looking at the dashboards. Microservices are great, but there are always things that probably you should watch or things that you should think on improving. As I mentioned, communicating over the network became harder with microservices. There is extra latency, there is more complexity, it's harder to debug, so keep in mind, make sure you're protected. Distributed systems creating a lot of complexity. You need to also be aware what are you releasing at what time. Data storing is a very interesting topic. How do you design your databases now? Is it shared database? It's a single database. If we go into microservices, do we need to break the database? So the data storing is really important, as well as how do you share it between services. And of course, testing is always hard. Make sure you can think about it upfront. So this is basic repository skeleton to start. Basically, after having your code, I would recommend starting making makefiles, which actually can package your application, try to use Dockerfile, add some Kubernetes specs. This site doesn't have things like maybe a Terraform or cloud formation. So these things I don't expect developers to have, and that's why it's not on the slide. So the summary of my talk is here on this slide. Basically, I think, as I mentioned before, Go is a great language to write microservices. By my experience, by the tooling up there, as well as by benefit of the language. Building microservices is hard in the beginning, so that's why you should maybe understand what you're trying to build first, and then understand what kind of infrastructure you want to build, and then after that, understand the concept of your scalability. So if you're having a complicated system, you should go with microservices, but I can clearly tell in certain ways, if you are delivering something pretty simple, you'll probably be okay by just using a monolith. So this is the end. Thank you so much.